Hi class, we are going to study the last section of the chapter 1. You guys been doing good, and this is going to summarize why we did those equations and functions, and then I'm going to help you using the rate of change and limit, approaching to a little bit closer to derivative in calculus. So 1.9, it will be some question you have seen, but listen my explanation very carefully. Before we are going to start, I actually gonna put you have link class activities first. So let's read our appetizer question first. So appetizer says, now we wanna evaluate limit when x goes to 3 as x minus 1 over x minus 3. Where does the limit goes? Just think about it as soon as you look at this limit. Also, if you think about today's title is we are going to use algebra to find this limit, but sometimes we can, sometimes we have to check with it, plug in some points. So what do you think the limit will be? So if you see it, that's good. If you don't see it, either way, I want you to graph it. So I want to pause the video, and as you see some of my work, do not look at it, and then pause the video. I want to graph this one, and then mine as well. If you have a chance, think about this question and then graph this one. That will save me a little bit of time. Okay, go ahead. Okay class, let's look at my graph and then try to see if you got the same answer. And here is my word. Also, I tried to find my horizontal asymptote using now limits instead of taking long division. So I want you to also practice like my way. So now when I look at this one, can you answer what is the limit x approaches 3, x minus 1 over x minus 3 will be? Okay, what's your guess? Answer is do not exist. Did you get the same answer? Young, I put it as infinity. Actually, yes, that is a correct answer. But as I mentioned in calculus, if your limit goes to infinity, we keep saying that do not exist. So just remember, in limit goes to infinity means do not exist as answer. So this case, when you look at the graph, obviously you can see that from left hand side of the limit from 3, which here is going to be negative infinity. And then if you look at the right side of the infinity of your function, then it goes to positive infinity. In the definition of the limit, one goes to negative, one goes to positive, then we say that also limit do not exist because both are going to opposite at 3. So limit at 3 do not exist because going opposite. Also, you can say at 3 it goes to infinity positive side. That's also we say do not exist. So just careful when you look at the meaning here. So it goes in an infinity. But we just check this one with the graph. We have to actually also show a little bit in using mathematics here. So one of the proof that what we are doing is, I want you to actually think about these two kinds of number. 1 over million. And then there's another number 1 over 0.000001. So that's going to be 1 millionth place, and this is 1 over million. What will be this number? This number will be 1.000001. 6 zeros. That's a very small number. Almost close to 0. So we count this one as almost close to 0. Then if I have a 1 over very small number, what happened? Then that becomes actually 1 million. Let me put this one this way so that doesn't look like decimals. 1 million. Very big number. 1 over very small number is going to be big number, like infinity. So remember those are two informations. 1 over big number is going to be 0, and 1 over very small number is going to be infinity. So when you see this one, you could also guess 2. When I plug in 3, I know that my top is going to be 2 because it's a continuous you can plug in, but you cannot plug in the bottom. But I said that limit means a very small number, so I'm going to plug in 2.9. Then I get 0.1. Then that's going to be 20. But if I put it 0.00001, that number is going to be 2 million. So whatever this number now gets smaller, it turns out to be big number. So as using this analogy, you could guess this is a very big number, which we said do not exist. And this is the reason why. I want you to remember the second part, because the beginning part using graph is using pre-calc, but I explained to you using calculus material. So I want you to think about now, if you finish this part, I want you to answer this one with your way, okay? So now try to tell me does limit exist and explain to me, and I will get back to you after I remove it. Class, so let's compare the answer of the in-class activities 1, it should be 1. And when you look at this one, finally, did you get it graph this time? We've seen several times also on the homework, right? So I got the linear graph, and then I have a whole and -3. Hopefully you got same answer. So now, so far if you got the graph, did you answer the limit? Now I want you to answer the limit as x approaches -3. Is this function has a limit? Okay, I want you to think about before I say the answer. Yes or no? This time, the answer is yes. We have a limit. What is it? That's going to be -5. Why? Because look at, we need to check the limit from x approaches to -3, negative side. Then as I see that my function is approaching closer to the -5, then also I'm going to check coming from limit as -3 positive side. Then also it is going to -5. So if left hand limit, right hand limit, if they are going same direction, then although the function value do not exist, the limit exists as a -5. Just think about this way. Everything around that number is towarding to -5. The AI is telling you they are all going to -5. Then where that number should be merging to, it should merging to -5. So actually limit exists, and that's -5. And hopefully you got it. Okay, I want you to see the difference is continuous and limit. This one is not continuous, however limit exists. Then yeah, that's how we can explain here. Then now I want you to think about next 3 things. So this time, using the graph, where does infinity goes to as x goes to infinity? Where your function goes to as where does your function goes to as x goes to infinity? So the graph is gonna be continuous, so infinity. How about next one? Can you guess that? That's going to be -infinity. Oh, Younga, you said that do not exist. Yes, that is the correct answer. That's the correct answer. So when you do homework, make sure you do this way, do not exist. And then last one, how about when limit goes to 0? Wow, that big. at 0 it is a continuous function, so I can say that that's my limit, which is -2. Hopefully by doing 3 sections of breaking, you're understanding limit a little bit better. Okay, so now we are going to have a main dish of 1.9. And as you see, we are going to study again about the rate of change. So this time I will explain to you one by one. So those who want to do by yourself and compare your rate of change, that will be good. If not, just also go over together with me with my explanation. So I want to find the rate of change, and we will see why we're doing this one, this section, and then the 2.1. So keep joining me. So rate of change is f over a plus h minus f over a over h. I'm going to plug in carefully. So f over a plus h, plug in here. It's not gonna be simple. A plus h minus 3 over 2 times a plus h plus 1. So I finished the first circle part. Minus f of a will be big parentheses a minus 3 over 2a plus 1 over h. So I replace this one into my function. So now we need to multiply common denominators. Denominator I'm gonna multiply 2a plus 1, 2a plus 1, top and bottom. This one, you have to be careful. I'm multiplying 2a plus 2h plus 1 after distribution. And multiply 2a plus 2h plus 1. And then same thing, we are going to multiply top. This one procedure will be a little bit long, so I want you to be very careful when you foiling out. So I'm going to use this whole part and foiling out carefully. It's going to be very long, but once you be careful, first part, it should be rest of them good. Organize the denominator since I see it. Denominator 2a plus 1, and then 2a plus 2h plus 1. As I see, already have a common denominator. And then since I don't have a board space, I'm gonna pull out keeping the negative and then using opposite sign, just to keep listening to me. So let's FOIL it, this factor to that factor. That's gonna be 2a squared plus, I'm going this way, 2ah minus 6a plus a plus h minus 3. Okay, so I did for 6 terms, and then I'm going to multiply this to this, and then negative sign. I will show you how I do. You can do your way too by distributing. Since I don't have a room, I will just squeeze it here. So multiply using distribution property, 2a squared plus 2ah plus a minus 6a minus 6h, hopefully it fits, minus 3. Okay, so that's what I got. So as you see, that negative has to be distributed. So that means 2ah will be negative 2ah, and 2ah will be negative 2ah. So you see that I can cancel out the terms that opposite. So minus 6a, there will be plus 6a, cancel out, and plus a, there's a negative a. So you will see, if your math is correct, a lot of them cancel out and turn it into fairly simple. So for me, everything turned out canceling out as opposite, and I have this h, careful about that, negative makes positive 6h left. So together is 7h. Again, I know what I forgot. Careful about denominator h, because I was focusing on big work that this h I forgot, which actually I can squeeze here. Divide by h means times by 1 over h, times by 1 over h. And we can reduce this one each other. So my final answer is a 7 over 2a plus 1 and 2a plus 2h plus 1. Okay, I hope that you got same answer of rate of change. Then, now what do we do here? Why did I make you doing all those long algebra work? Because we want to find the limit. And what we apply, this is the derivative definition, because derivative means slope. So I actually put it into slope formula. This is a slope formula. I'm going to explain 2.1. So just get algebra done here. And then from here, I have derivative slope function. If I take a limit of the slope, that is the definition of derivative. So I had my simplified version of my rate of change. Then let's take a limit, and now I wanna take h goes to 0. That means I wanna try to make the 2-point gap smaller. So wait for next section. So 7 over 2a plus 1 and 2a plus 2h plus 1 is equal to, what happens is, if you plug in 0, you can plug in 0 here, still it's going to be okay. I get 7 over 2a plus 1 square. That's what I get. And that is the derivative of this function. This is the derivative of this function. Okay. So if you understand the meaning in here, then I want you to try in-class activities one more time. I want you to get the rate of change and then try to find your limit of as h goes to 0 and see what will be your derivative function. So this is we call as a derivative function in the future. Okay, so try in-class activities. So let's check the answer for in-class activities 3. And when I take the rate of change, I got the answer 7 over the denominator. And after I take the limit as h goes to 0, then I got the answer was 7 over 3a plus 1 complete square. So when I look at this one, I will try to explain brief explanation why we're doing this one. Also watch 2.1 lecture, we will go also same explanation there, but I want to graph this function briefly. As you see, denominator cannot be negative 1/3, so I'm going to have vertical asymptote. When I look at this one, horizontal asymptote is going to be 1/3, and then by plugging 0, y-intercept is going to be negative 2, and then if I plug in 0 as a y-intercept, I see that x-intercept is going to be 2 as well. So I see graph shape is gonna look like this way. Then what does this mean? So that's the function, but they are asking about what is this. I wanna find what is this slope. I wanna find what is the slope. Then usually you find 2 points to get a slope, but in calculus you already take the limit that we can find the slope at 2. Just plug in here together with me. If I plug in 2 as a is 2, then I get 7 over 2 times 3 is 6 plus 1 is 7 squared, 49. Okay, double check. 6, 7 squared, 49. Then what does this mean? At 2, actually this slope is 7 over 49. That's what they're saying. Then, Young, can we find when slope is 0? Yes. So now I'm going to plug in a, you can guess as x, same thing. So let's plug in a as a 0. So I'm going to plug in 0, and then now when I plug in 0, I get 7 over 1 squared, which is my limit of a rate of change says that it's gonna be 7 because it's a 7 over 1 after you plug in 0 here. That means the slope at 0. What is this? That is 7. So what you did, you programmed it. I just punch in number of x value, then you made it pop it up with your derivative. If you don't believe me, you can plug in -1 again. If you plug in -1, that's with -3 plus 1 is going to be -2. Is that right? And then -2 squares of 4. So I'm gonna have a 7 over 4 has my slope right here. That's what it means. So now I want you to, anyway, 7 over 49, I thought that that's big, but now if you think about that's 1 over 7. And, I see something really cool. Do you see that? This is a reciprocal. Wow, they're somehow very correlated. That's why calculus is fun. So I want you to understand, and then you should have some wow part in here, and hopefully you're enjoying some calculus here. So pause and think about it while I'm removing the board. Keep trying with me. So now we're gonna talk about dessert. I hope that you understand main dish and enjoyed it. So dessert part of the 1.9 is what we're gonna do if when you look at the limit, we cannot evaluate right away. So we are going to talk about when limit not exist. Before we do, we can think about this example we have seen before. What is my function? It is a quadratic. If it's a quadratic function, how do we find the limit? Can I plug in number in here? Yeah. Why? Because this function is continuous everywhere that I can plug in number in order to find the limit. So if I plug in 5, that is going to be 2 times 5 squared minus 3 times 5 plus 4. Let's do quickly. That's going to be 15 minus 15 plus 4 is going to be 39. So I see the limit goes to 39. However, let's look at A, B, C here. So when t approaches 9, when I plug in, that makes undefined. So I want you to think about how we're gonna approach. Also, you can plug in top. Still, that's going to be undefined. Next one, can I plug in -4? Same thing happened. Last one, can I plug in 0 in here? Same thing happened. So how are we gonna evaluate this one? Should I say that do not exist? No, we cannot. We have to do small algebra that we learned in algebra and pre-calc class. Then we can rewrite these expressions. So how we rewrite these expressions, we are going to multiply, conjugate. Do you guys remember multiplying, conjugate? So in this case, my top is going to be, say 9 minus t times 3 plus square root of t. But if you do denominator, did you notice that a minus b, a plus b equation? So that makes 9 minus t again. And as you notice, they are same factors, good thing. So we factor it out, and then I got only 3 plus square root of t. Then can I plug in my limit t as a 9? Yes, because this is now continuous function. 3 is continuous, root t is continuous. When you add it, then it's going to be continuous by the property. So this is continuous. So by plugging 9, I'm going to get 6 as my limit. Okay, let's look at B. Then how do we compute? When I look at -4, that will make denominator 0. That's not gonna work. But probably I can rewrite these expressions. So I can rewrite as 1 over 4 plus 1 over x over 4 minus x. Then what? Well, we gotta make a common denominator as we learned, multiplying x and x, multiply 4 and 4. So let's see if I can manipulate a little bit. Then this turned out to be 4x as you see here. Top I'm going to have x plus 4 and bottom I'm going to rewrite x plus 4 and don't rush. That means an over 1. You know, I forgot the expression. It's okay. Just think about your elementary teacher taught you. What does that mean? Divide by x plus 4 means multiply by the reciprocal. Divide by the number means multiply the reciprocal. So I rewrote it and then cancel out. It simplifies as 1 over 4x. Therefore, now I can plug in finally negative 4. I get negative 1 over negative 16 as my answer. Okay, one more, almost there. So next expression, also I cannot plug in 0. Then what should I do? Similar idea, I'm going to multiply the conjugate. And make sure you understand conjugate same as mine. Then let's see what's gonna happen. What's gonna happen? Numerator I say a minus b, a plus b. So I can write as a squared, which is 1 squared minus 1 minus x squared is going to be this. If I'm taking square of that one, it comes out as just 1 minus x squared. And then careful about subtraction. If not, just fold it out. Denominator, I have x over x plus square root of 1 minus x squared. So from here, I'm almost done. If I simplify, numerator, I get only x squared. Because the negative 1 cancel out, plus x squared. Denominator, I have x that will make things nicely. So this cancel out, and I'm going to have only 1 over, x over denominator, like this. Oh, did I put square root twice, right? I shouldn't. That should be parentheses. However, now will be okay 0 over the number. Yes, you can have a 0 over the number. So since numerator is okay to have 0, this one, after all the hard work, it goes to 0. Goes to 0. So that's the answer. Now, I want you to try next 2 in-class activities. They're A and B with a very similar work. So do it and then compare the answer with me. So how did you do your in-class activities 4? Is it getting better, class? So first one, get my work here and I got the answer 1 over 6. Second one, also compare my work too, and I got negative 1 over 9. If you got the same answer, that's very good. If not, just go over with my work. Usually it's a very silly mistake. So please go over and hopefully you got the same answer. So we actually finished chapter 1. Yeah, and chapter 1 is done. And please finish the adaptive practice by June 29th. So since we finished the chapter 1, just keep do adaptive practice as much as you can until you can impress you and me. So that's going to be by Monday, June 29th. But before that, we're actually gonna have, as I promised, I'm gonna make all the deadline Monday. So by same day, we are going to also have exam number 1. I'm going to have a little bit and I will let you know more about it next time. Okay? Alright, so that's it.